Alright, hello everybody and welcome to your video notes on 7.3 at the meets level. Meets level is just I can calculate a net force when the forces are at an angle. Ooh, oh boy. Alright, so go ahead and pause the video and write down this problem here and try to copy down this beautiful picture that I've drawn for you. Now that you have that written down, let's go ahead and get started. A man pushes a block of ice to the left at an angle of 35 degrees below the horizontal with a force of 80 newtons. The block of ice has a weight of 550 newtons and a normal force of 595.9 newtons and is accelerating despite a force of friction of 35 newtons. We want to find the net force of the block, and we want to find that in the x and y direction. Okay? So first you need to step 0, draw a free body diagram. I'm just going to go ahead and show you that. Okay, we've got a free body diagram right here. We'll zoom in on that a little bit. So what we can see here is we've got the force of friction that's going in the opposite direction of the motion. Normal force is 90 degrees to the surface, force of gravity is down, and then the push is at an angle like this. Then as soon as you see that there's something at an angle, you should automatically go into autopilot and know that you need to calculate the x component and the y component for this. Okay, so that's what we're going to get started with first. So I'm going to go ahead and redraw this over here. So I've got my triangle. It's going to look something like this. I've got my angle here, which is 35 degrees. And then my total, or the resultant, let's see, it says in the problem, pushed with a force of 80 newtons. So I'm going to write 80 newtons there. And I call this x, and then we call this y. So then, let's go ahead and calculate that. So we've got the x direction. And the way we're going to calculate that was with sine, because the ka in SOHCAHTOA says adjacent, which is this, or you can just remember that cosine is always going to be for the x direction. So we've got the cosine of 35 degrees equals x over 80 newtons. Then we're going to solve for this. We end up with 65.5 newtons. And then we're going to do the same thing, but in the y direction. We're going to use sine for this one. So you can either just remember that it's always sine, or so in sine the O would be opposite, which is what we're doing there. And that's where we end up for our components, 45.9 newtons and 65.5 newtons. So now we have calculated, so this is like step 1. Then I'm going to swap colors for step 2. Step 2, we're going to make our list of our variables. So we've got our x direction, and we've got our y direction. If I look back at my free body diagram, I've got the force of friction that's in the x direction. And that is going to be positive because it's pointing to the right. The problem says that that value is 35 newtons. And then we've got this bad boy over here. The force of the push that's in the x direction is going to be negative because that's pointing to the left. And we just found that was 65.5 newtons. Okay, that's it for the x direction. And then for the y direction, we've got the normal force, which we're going to say is, let's say Fn equals a positive, and the problem says 595.9 newtons. And then we've got this force of the push in the y direction. That's this bad boy over here. This is also negative because it's pointing down, and we found that to be 45.9 degrees, or sorry, not degrees, newtons. And then the last one is the force of gravity. It gave us that in the problem. It said that we have a weight of 550 newtons. So remember that weight is the force of gravity. Okay. Sidebar. If the mass is given, find Fg by Fg equals mass times gravity, and that's always negative 9.8 meters per second squared. Okay, so so we're going to find the force of gravity by doing this equation. So, little sidebar, this one, the force of gravity was given to us, but if it just gave us the mass, which is always in kilograms, we would find it by doing that following. And then the last thing that we're going to do, so back into it, the last thing that we'll do is step 3, where we're going to combine the forces. Okay, so we've got the x direction, and I'm just going to take these values here, I'm going to write them over here. So I've got my 35 newtons minus 65.5 newtons, and I end up with negative 30.5 newtons. So we'd say that that's going to the left. And then the y direction, I'm going to take these values and write them here. Got my 595.9 newtons minus 45.9 newtons. Oh, I forgot something, folks. Force of gravity is indeed negative, because I have to subtract that here, minus my 550 newtons, and I end up with 0 newtons for my final answer. So this one and this would be my final answer. Thanks for listening.